In this lesson, we're going to learn how to describe function transformations, and the type of transformations we're going to focus on is reflection. So how are we going to approach this? We're going to explain what function transformations are. We're going to talk about reflections, the vertical and the horizontal reflections. We'll look at the technique for expressing reflection, and then we'll also look at how to do that in function notation, as well as use that knowledge to answer some questions together. So what is a function transformation? Transformation just means change. So you're changing from one form to another. And with functions, we're going to always start with the parent function. And then we will decide how the parent function is changed based on the transformation that we're given. So let's talk about reflection. Reflection simply means making an image. So when you have an image, you're always thinking about a mirror. So we have two types of reflection. We have a vertical reflection. We also have a horizontal reflection. So what is the vertical reflection? Let's assume that I have a shape like this, or let's not use a shape, let's use a point. If I have a point right here and I have a vertical reflection, that point is going to go down, because the vertical reflection means the reflection is up-down reflection. So it's going to go down the same distance from the x-axis. You can see here. So when we have a vertical reflection, the x-axis always is our mirror. Just think about a reflection. If you had a mirror right in front of you, would you believe that your distance from the mirror is actually the same as the image you see behind the mirror is the same as the distance that image has from the mirror? So that's the same concept we apply. But in this case, because we're looking at the vertical reflection and the reflection is up down, the x-axis becomes our mirror. Now, if we're looking at a horizontal reflection, we are going to go left, right, and you can see here that the y-axis becomes the mirror for that reflection. Let's talk about horizontal reflection a bit more. Horizontal reflection always happens with the input. So the input value is the one you can see. And when we say input, we're looking at the domain. So the reflection is happening on the domain. So if I had this right here, you can see here that the reflection happens on the domain. And when we are trying to write this in function notation, we actually always write this way: f of x, f of negative x. So that simply means that the transformation is happening on the domain values and is going to be left to right. With a vertical transformation of reflection, the reflection is happening on the range. So you can see right here, these are your range values. And remember that the x-axis is the mirror for this transformation of reflection. And we're going to always write it this way: f of x is going to transform to negative f of x. When you see the transformation happen on the range, you're going to see that it's going to be outside of your f of x. If it's happening on the domain, it's going to be inside of your f of x, which is inside of the parenthesis. Now let's do some examples together to put all of this understanding together. Express this transformation in function notation. Function f of x is reflected using the x-axis. So what I'm going to do here is I'm just going to draw something that looks like my axis. It says that it's reflected using the x-axis, so that means that my reflection is going to look like this. So that simply means I'm going to have a vertical reflection. So it's going to be f of x to negative f of x. That is my vertical reflection. So it says the function f of x here is reflected using the y-axis. Again, I'm going to draw. This is my y-axis. If I have a reflection using the y-axis, it's going to look like this. So we're going to have f of x being reflected using the y-axis. So it's going to be a domain reflection. That means we're going to make the reflection inside of the function, inside of your parenthesis of f of x. So this is your input is the one that is getting reflected. So it says here that the function f of x is reflected using the y-axis and then reflected using the x-axis. So I'm just going to draw this generally. The function is reflected using my y-axis. So I'm going to first have, so let's go with f of x is going to be, first we're reflecting using the y-axis. So it's going to be f of negative x. And then it is reflected using the x-axis, which is going to be a reflection on the y-axis. It's going to be a vertical reflection, or we can call it a range reflection. So that's going to be that. So that's how you would manipulate. You would derive your function based on the description of the reflection. Now let's go ahead and look at these examples here. Describe the function represented by f of negative x. So I can write it in we can write it in maybe one of two ways, but I'm going to write as many of them as possible. So we're going to say this is going to be a y-axis reflection. Okay, that is one way to look at it. The other way you can see this is a horizontal reflection, because the reflection happens on the horizontal axis. Some may even call it a domain reflection, domain values reflection. That's not as commonly used. You can use these top two are the most commonly used wordings to express, or statements to express this type of reflection. And then finally, describe the function represented by negative f of x. So we can call this a vertical reflection, and we know it's a vertical reflection because it is happening outside of the f of x. We can also call it an x-axis reflection. And then we could also say it's a range values reflection. Like I said earlier, this is not as commonly used, but these two are the most commonly used ways of expressing this type of reflection.